I'm Ulises Moya, and this is a tutorial for AI for deforestation. So maybe you used this before. You need only to push this button in order to run the cell. There is a two kind of cells. There is a code cell, and this is a test cell. So as I say, I'm Ulises Moya. I work in Instituto de Información Estadística y Geográfica de Jalisco, Mexico. Maybe you hear about Jalisco because there are here a lot of mariachis, tequila, agave, these kind of things. And actually, I worked before in this kind of problems about deforestation. This is a report about how we did in other technique. And in this tutorial, we use a deep learning technique in order, actually we use three different kind of models. One is random forest, the other one is 1D convolution, and the other one is time series transformer. And this is the data set. Actually, this is the site where I get the data sets. You can check this, and this is all the area that they monitor about deforestation. But we only detect in maybe this area some points about this. Okay, this is the outlook of this notebook, and you can check the overview of the notebook. As I say, we use actually Sentinel-2 data, and we use one dimension CNN, and we compute this index in order to see how much green are the parts. And we use another data set called Alfire, which is actually 64 embedding image. And if we use this data set, we can see later that the results are very good. So, of course, you see what is the climate impact about this, about the deforestation. So this is very important. And here is some background about the NDVI, this index about the greenness of the image. We can see that this is, we use a satellite image time series. So this is important because we don't use only one image. We don't use the detection technique. We use a time series in order to classify if we have deforestation or not. This is the requirement. You can check here the full list of requirements, also the repo. Of course, I run this before. We run with CPU, but you can change here in the notebook settings if you want to use GPU for this example. We have this data around this area. This is the size of the area that we study with only 980 samples or pixels, and we have three classes: forest, deforested, and all clear. Okay, so if you want to download the data, you can run this. And you get the data from here, from my repo. You can check this. If you want to see the code, how I download this, you only get the data. It look like this. The position of the point, the label, and this is the NDVI from each month. Okay, you can check this like this. There are 24 points. And you can see here in this animation how it looks. Okay, so if we pass from this, more or less, this point, it could be deforestation area, okay? So we have a lot of time series data, and we need to classify. So We have these data sets with these numbers um, of labels, and we have very imbalanced data set. So this is how looks the NDVI time series mean and standard deviation. And if you can check how looks the same label with different samples like this. So you can check what happened if we, for instance, use instead of 510, looks very different. So the classification is not an easy task, okay? So here we prepare the data set, we split the data into parts, the train part and the test. You can use also a validation part, but only to put in simple in this example, we only use these two splits, okay? So this is how it looks in the space, the three classes, and this is the training area, and this is the validation area. So we use three methods, as I say. This is the random forest. The random forest is a machine learning method. Maybe you hear about this. And we have two metrics here, the accuracy, but remember we have a very imbalanced data set, so we need to check another metric called F1 score. This is the best way to see if the models performs very well. Okay, this is how we define the 1D convolution. This is an schema about that. This is the time series. The time series works very well with the time series transformer. The transformer is maybe the best technique so far to time series the data set. And we have a very small transformer, but you can change the model size or the number of heads. So if you change this, you can get better performance, okay? So this is how it looks the transformer. And this is the training path, okay? Of course, I trained it before in order to save time, and you can check the loss and the test accuracy of both models. This is how it looks, the training of 1D convolution and the transformer. In this case, a small loss is better. In the case of the accuracy, higher is better. So we can see that maybe the transformer have better performance than the convolution, but let me check this in this way. We create some code in order to compare these three results. We check the accuracy, the F1 score in three cases, and you can check that we have better F1 score in the random forest. Oh, we have a problem. Yes, actually, if you run again this example with more heads or more different sizes, as I recommend here, you can check that the performance could be improved. Here is the recommendation. Okay, increase the layers or the number of heads. Okay. Okay, so this is another way to see that the result. You can check the confusion matrix. If you see the 1D confusion matrix looks very bad because don't detect any case of deforestation. In this case, in the transformer is better because they detect at least six in the confusion matrix. Of course, the diagonal is the best way to measure this. And also you can check what happened if they predict as forest, but this is actually all clear what happened with this technique. So you can check maybe if there's something wrong with the labels and so on. This is the last part of the tutorial. You can check this alpha earth. This is foundational model in order to have a 64 channel image, and you have an embedding of remote sensing image, where you have the multiple channels, weather channels, and so on, and embedding in 64 channels. If you want to download these datasets for this tutorial, you only have to click here. It's easy way to do it. But if you want to download another one, you need an account to do it. So maybe you have to do something in order to use in Google Earth Engine or Google or GCP. Okay, this is how looks the datasets. Again, we have the position of the point, the label, and we have the 64 channels. Actually, this is one embedding per year with 64 channels. So maybe you can download the dataset like this, and this is how looks the split in these datasets. Please check this. We don't use these years. Actually, we have until 24, but the label is from 2022. So if we use more than this year, we will have problems about the data leakage. So this is the training path. If you see, this is a better performance. If you compare with the others techniques, you can see that we have better accuracy, better F1 score, and better recall. So this is the best model that we have. And this is the confusion matrix. You can see that this is a better performance of the model. And okay, again, you have to take care about this data leakage problem. If you use more than this year, would be a problem. Yes, of course, this is a technique that only show how it works. If you want to do it, you need more area, more computational power, and we have a lot of things that you can check here about if this can use for production. Of course not, but this is a nice way to start. Okay, at the end, I can show you how to download one NDVI from certain point. So you can check here. For this case, you don't need to have any yes, any credential or something like that. Okay, so that's all. You can check the reference of that or the next step. If you want to check the report, you can check and see all the codes. And I have some slides about this. So I hope you enjoy this. Thank you.